My name is Nelson Rivas. I'm the president of Matrix Railway. We are a railroad company. We make locomotive and commuter rail equipment for the Transit Authority. Today, I want to talk about something very special and dear and close to my heart, which is one of the most satisfying and challenging fields that an engineer can undertake. So this field is called obsolescent solutions. So what happens on trains, we're building equipment that's going to last 30 years. Most of the equipment that we build is works in critical parts of the trains. So it's very important that the equipment is rugged, can withstand high temperatures, very cold temperatures, high vibration, and it has to sustain waves of electromagnetic emissions, high voltage spikes, and so on. So by virtue of having a component that is very rugged, it tends to last a long time. So most of the designs I work on will last 15 to 30 years. And that's a tall task for any engineer, because if you buy anything in Walmart or Home Depot, you will see one thing, like 30-day warranty. We got to give 15 years. This thing is going to be in the train for a long time. So therefore, after so many years, the train, after 15 years, a lot of the technologies, they just disappear. A lot of the products, they just don't make anymore. We go from, SCRs to GTOs to IGBTs and, all kinds of different components that evolve over time, and they become faster, cheaper, smaller. They use less power and so on. So most of the time we get commissioned, take a part that's 15 years old and make a new one out of it. The interesting thing, or the most challenging things for me, and very satisfying, by the way, is that I can take an old component and bring it up to today's standards using today's new components and new requirements and new standards that the government issues for those particular applications. So we have here three components. One component is a light. This is one of our core systems. This is a light that was made about 25 years ago. It is in here. This is a compact fluorescent, and the light output is extremely low. And guess what? My customer got a phone call from Sylvania, or one of these companies that provide the light element that fits there, compact fluorescent, and they're just not going to make it anymore. You've seen Edison lights, the one that's screwing light bulbs. Well, they're going to disappear. The compact fluorescents are on the way. They have mercury. It's dangerous to you. It causes all kinds of diseases. It can kill you. So they're doing away with this light. Using LEDs, which is light emitting diodes, we can take this light, and all we have to make a new one and do this and illuminate the area that this light was designed to do. But since now we have LEDs, LEDs are a lot more efficient, let's say, than compact fluorescents. And I can be specific, they're like 4 times more efficient. So the power that we use in the train to run an LED light, which is this particular light, is going to be 4 times less. And if you look at it side to side, you're going to see it's going to take less room. Okay, and this way it's going to eliminate more and cover more area. This light that we did, it took us a whole 6 months to do, and it was in the train and still working for 3 years right now. Brand new. But this is where it started. Then, other things is that sometimes, like this electronic board, this is another obsolescent solution exercise. This application is for a board made by General Electric. So they decided that they're not going to make this board anymore. And not only that, some of the components here that you see, these factories stopped making these components 20 years ago. So for me to take this design and upgrade it according to GE standards, okay, it's an exercise and it's a lift. Some of these components we have to buy. There's just no way out of it. So we have to look around the world to buy these components, and we sit together with the engineering team at the Transit Authority. For example, this is for Pennsylvania Railroad. We actually replace all these boards on the entire fleet for the Silverliners because they could not get service. They couldn't get spare parts. They couldn't get service from GE, and they couldn't buy spare parts because the factories have pretty much stopped making these parts. So again, this is the board we made for them. We're using the exact components that GE mandated on their design, and this particular board was designed along the guidelines of the engineering group in Pennsylvania. So the guys over there, pretty good. They know what's going on. They know all the failure modes. So we purchase all the components. We lay out the board. We make a little face plate, a little different. It's not blue, it's black right now. And right now, we're down to 0 failures on these boards. That's pretty good. So the entire fleet for SEPTA, which is Southeast Pennsylvania Railroad, is in good shape right now. And that's why all the people in Pennsylvania are very happy when they get on these Silverliner trains, because they don't have that many delays anymore. Okay. All right. This particular board here is another one. It's another obsolescence solution that's for a trolley in Pennsylvania. A lot of these exercises that we do in obsolescence solutions, it's not high volume, but it's very interesting. The equipment is very old, and they only need 30 pieces, so it's 30 pieces and out. So if you're looking to fix your train and you only need 30 pieces, talk to us. We would be more than happy to help you. But this particular board is for I believe it's for the doors of the train. I'm not quite remember what the application was, but they couldn't buy this anymore. And the design is kind of interesting. It depends on this series of resistors that are at the edge, getting hot or getting cold, and that's how they control a certain function in the train. Also, if you look at the top over here, it has this little silver-looking lines, and that's like an edge or knife edge board that you could take and you put it in an electrical panel like that. So we got no schematics. They said, here's the board. We need 30 of them. Okay. So we analyze the board, figure out the function, make mechanical drawings, make electrical drawings, make manufacturing drawings for this board, send it out to be made, and voila, we make this guy, which is identical, form, fit, and function as per the specifications of this manufacturer, which was particular Alstom, I believe, board for these trolleys, which made the cars a long time ago. Again, we have gold contacts instead of silver, so that improves, the conductivity of the electricity coming in and the signals. And we also, at the bottom of these particular devices, we put a special heat sink compound that does not allow these resistors to overheat and burn. That was an improvement. That's what the engineering team at SEPTA and us decided that would be the best solution. And we made it for them. And that's it. We made 30 and we haven't heard from them. 0 failures. So if you're an engineer looking to have an exciting time, get into that field. And if you are a transit authority looking for a board or something that nobody wants to make for you anymore, give us a call. We're here for you. Thank you.